Look around you right now. Every smartphone in your pocket, every washing machine in your laundry room, every drone in the sky, and every laptop on your desk, they've all got tiny computing brains inside. But here's the fascinating part. They absolutely do not all use the same kind of brain. Some are built to crunch billions of numbers a second, while others are masterfully designed to control just a single motor or sensor with unwavering efficiency.
So that brings us to a really fun question to kick things off. Why on earth does your laptop need a fundamentally different brain than, say, your kitchen microwave? After all, your microwave doesn't exactly need to run Doom, right? Today, we're diving into this explainer to unpack the two most important computing devices in the world, microprocessors and microcontrollers. They might sound incredibly similar, but trust me, they power completely different worlds.
All right, let's jump right into section 1, the contenders, brain versus body.
To truly get a handle on our first contender, the microprocessor, I want you to imagine a human brain. A brain can think, right? It processes incredibly complex thoughts. But without eyes to see, without ears to hear, and without muscles to actually move, it can't function on its own. It's basically isolated. Well, a microprocessor is essentially just a CPU, a central processing unit. It is purely the calculation engine and nothing else. On its own, it's literally just that brain in a jar. It absolutely requires external components to actually do any work.
So the crucial point is that this chip is incredibly needy. Think of it like a brilliant but highly demanding CEO. To get anything done, it demands a massive external support staff. We're talking RAM for short-term active memory, a storage drive for long-term memory, and complex buses linking to all your input and output devices like keyboards and monitors. This is exactly why the inside of your laptop looks like a sprawling digital city. It's built entirely around a microprocessor that demands this complex motherboard to connect everything. Now let's pivot and imagine something totally different. What if you took that entire sprawling digital city and somehow miniaturized the whole shebang, packing it into one single tiny chip? Well, that is a microcontroller. It's a complete mini-computer integrated entirely onto a single integrated circuit.
When you crack open that single chip, you don't just find a CPU. Nope, it's packed with its own flash memory, RAM, timers, and GPIO pins, which are basically little digital legs used to control motors or read sensors. It even has built-in communication modules like UART and SPI, so it can talk to other chips. This all-in-one chip is designed specifically for controlling devices super efficiently, rather than, running heavy operating systems.
Moving on to section 2, the spec showdown, architecture, speed, and power.
Now that we know what these brains are fundamentally, let's see how they stack up head-to-head on the spec sheet. First up, architecture. A microprocessor depends on a complex web of external wires and components, which makes it pretty bulky. But the microcontroller? By keeping almost everything internal on that single IC, it's significantly smaller, vastly cheaper to produce, and highly reliable because there are just fewer external connections to fail. It's the perfect recipe for embedded systems.
And this brilliantly illustrates where things really start to diverge. Top speeds. Microcontrollers might max out around, say, 480 MHz on the extremely high end. But microprocessors, they scream past 5,000 MHz. That massive speed advantage is absolutely crucial for multitasking and running heavy operating systems like Windows or macOS. Microcontrollers simply specialize instead in reading sensors and running hardware.
It's the exact same story with memory. Gigabytes versus kilobytes. Microprocessors require huge amounts of memory, gigabytes of RAM for complex, unpredictable tasks. Microcontrollers, on the other hand, live entirely in the tiny world of kilobytes because they just need to store a single, highly efficient firmware. Crazy fun fact, the tiny microcontroller inside a modern smart plug often has more memory than the computer that guided Apollo 11 to the moon.
But all that speed and memory comes at a serious cost. Power. If a microprocessor is a high-speed sports car, it guzzles energy like one. It drains batteries rapidly. Microcontrollers are the total opposite. They are hyper-efficient champions that can literally drop into deep sleep for months, sipping mere microamps of current. A laptop drains its battery in a few hours, but a coin cell battery powering a microcontroller can run for years. That makes them pure magic for wearable devices and remote IoT sensors.
Let's head into section 3, the real-world arena.
So, where do these silicon brains actually live in our world? Well, here is microprocessor territory. Laptops, desktops, gaming consoles, smart TVs, and massive AI servers. These are your heavy-duty devices. They're constantly multitasking, rendering graphics, and crunching huge datasets.
They absolutely require that massive calculating power that only a microprocessor can deliver.
But here's a wild number for you, 50 to 100. That is how many microcontrollers are inside a single modern car, silently working behind the scenes. They manage your engine timing, deploy airbags in milliseconds, and run your anti-lock brakes. You interact with dozens of them every single day without even realizing it. They're in your microwave, air conditioner, smart locks, traffic signals, and even life-saving medical devices.
Okay, let's dive into this and summarize the definitive differences across all the core metrics in one clear view. Microprocessors are your high-power, higher-cost, general-purpose engines that rely on external memory and heavy operating systems. Microcontrollers, they're your low-cost, hyper-efficient, all-in-one chips purpose-built for embedded systems, and they do it all without the heavy OS overhead.
Let's wrap things up with Section 4. Which one should you learn?
If you're picking up a new hobby or looking at engineering goals, the landscape divides pretty clearly. If your goal is building robots, flying drones, playing with Arduino, or creating IoT systems, your path definitely starts with microcontrollers. But if your dream is mastering the Linux kernel, configuring high-performance computing, or running AI servers, then you've got to study microprocessors. Though honestly, eventually learning both gives you the absolute strongest foundation in tech you could ask for.
So, as our ultimate takeaway to make sure you never confuse the two again, remember this core metaphor. A microprocessor is a brain needing a body. A microcontroller is the complete body and brain packed inside a single chip. Keep that in mind, and you'll always know exactly what these incredible devices do.
So, I've got to ask, which computing brain will power your next big project? Think about it. If this explainer helped you finally untangle these two very different chips, make sure you stick around. In our next explainer, we're going to dive even deeper and explore exactly how a microcontroller executes your code step by step, right from the moment you power it on. It's a fascinating journey, and I absolutely can't wait to guide you through it. See you next time.